Hi students, welcome to physics class. Today we will discuss about parallelogram law of vectors. The statement of parallelogram law of vectors says that if two vectors acting at a point, let us say p bar and q bar are two vectors acting at a point O, are represented in magnitude and direction by two adjacent sides of a parallelogram. If these two vectors can be represented as the adjacent sides of a parallelogram, that is here O, A, B, C is a parallelogram, and we can represent these two vectors as the adjacent sides of the parallelogram. P bar and Q bar are represented as adjacent sides of parallelogram. We know that in a parallelogram, opposite sides are equal. So, we can form remaining two sides with these two sides P bar and Q bar. Then what happens? Then the diagonal passing through their intersection point. Here O is the intersection point of P bar and Q bar vectors, and the diagonal passing through their intersection point is R bar. So the diagonal passing through their intersection point represents, what represents? They represents the resultant of these two vectors both in magnitude and direction. So R bar is the resultant, which is denoted by the diagonal, which is equal to resultant of these two vectors P bar and Q bar. So once again, see the statement here. If two vectors acting at a point, these two vectors acting at a point are represented in magnitude and direction by two adjacent sides of a parallelogram, then the diagonal passing through their intersection point represents their resultant both in magnitude and direction. Here P bar, Q bar and R bar are vectors. So vectors have magnitude and also have direction. So we say both in magnitude and direction. Here we are saying both in magnitude and direction because P bar, Q bar and R bar are vectors. So vectors have both magnitude and direction. So we will represent these two vectors both in magnitude and direction. Next we have to derive first one, the magnitude of resultant, that is the magnitude of resultant R bar mod or modulus of R bar, and the direction alpha. We have to calculate the magnitude of the resultant and the direction of the resultant. Let us say here theta is the angle between P bar and Q bar. Theta is the angle between P bar and Q bar. Here also theta is the angle between P bar and Q bar, and the angle between R bar and P bar is alpha. We have to find this alpha, that is the angle made by the resultant with P bar is alpha. Here in OABC parallelogram, opposite sides are equal, and we have to draw a perpendicular, foot of the perpendicular, and we have to extend OA, and we get a intersection point called D. Here it is theta, so opposite angles are equal, so we get theta. Here angle between R bar and P bar is alpha. In the figure we can clearly see that this is A, this is D, and this is C. Let us suppose AC is a vector and which is making an angle theta with x-axis, and this is y-axis. Then this AC, here AC is called as q bar because opposite sides are equal, so AC is represented as q bar. Then this q bar vector can be resolved into two components. First one is horizontal component qx, which is equal to q cos theta, and vertical component qy, which is equal to q sin theta, and this is also q sin theta. So by writing these components in the diagram, we get AD as q cos theta and CD as q sin theta. Now magnitude of resultant, we have to calculate the magnitude of resultant. For that, take the triangle OCD. In triangle OCD, by applying Pythagoras law, we get hypotenuse square is equal to side square plus side square. Here hypotenuse is OC. OC is the hypotenuse, so OC whole square is equal to adjacent side. Adjacent side is OA and opposite side is CD. So we can write, adjacent side is OD and opposite side is CD. OD square plus CD square. Side square plus side square. Next, OC whole square, which is equal to OD means OA plus AD. OD can be written as OA plus AD. So OA plus AD whole square plus CD square. Now substitute the values. OC is equal to R bar whole square, which is equal to OA means P bar plus AD means Q cos theta P bar plus Q cos theta whole square. We have written OA as P and AD as Q cos theta, and we have already square term, so we have taken the square term. CD means q sin theta. Q sin theta. Here r bar square gets r square. By expanding this term with the formula a plus b whole square, by using the formula a plus b whole square, which is equal to a square plus b square plus 2ab. Expand the term, p square plus q square cos square theta plus 2pq, sorry, 2pq cos theta plus, and squaring this term we get q square sin square theta. Next, in the step we can write p square plus, by taking common factor q square in these two terms we get q square into sin square theta plus cos square theta plus 2pq cos theta. And also we know that sin square theta plus cos square theta, which is equal to 1, that is this term will become 1 into q square becomes q square, so p square plus q square plus 2pq cos theta, which is equal to r square. Finally we get r is equal to square root of p square plus q square plus 2pq cos theta. This is the magnitude of the resultant. We have obtained the expression for the magnitude of the resultant. Now we have to find out the direction of the resultant. In the same manner, we have to take the foot of the perpendicular here, and we have to extend OA, and we get an intersection point D. This is q cos theta, this is q sin theta, this is the angle theta. Opposite sides are equal. This is the angle between resultant and the vector p bar. Now we have to calculate the direction of the resultant. Direction of resultant. Now take the triangle OCD. In triangle OCD, apply tan alpha. Here the angle in the triangle OCD is alpha, so we have taken tan alpha, which is equal to opposite side by adjacent side. So the side which is opposite to the angle alpha is q sin theta, which is equal to CD. CD divided by adjacent side is OD. That is equal to CD divided by OD. OD can be written as OA plus AD. So OA plus AD. By substituting the terms, we get CD as q sin theta. Q sin theta divided by OA is p bar, so p plus AD means q cos theta, q cos theta, which is equal to tan alpha. From this we can obtain alpha, the angle made by the resultant with the vector, as alpha is equal to tan inverse q sin theta divided by p plus q cos theta. This is the direction of the resultant, that is the angle made by the resultant with p bar. This gives the direction of the resultant. That's all. Thank you.